right, so today all we're really doing is solving square root and cube root equations. So we're solving square root and cube root equations. Now, we took algebra a long time. Put that away, please. So we took algebra a long time ago. But one of the things we learned about algebra was solving equations, right? And we solve equations, we're always solving for x, right? Always solve for x or y or whatever, solve. But in an equation, the trick was to undo things by doing the opposite. Say it again. The trick was always to undo things by doing the opposite. So like if it said subtract 4, you would add 4, right? The times by 2, you divide by 2, right? Always doing the opposite. So we're going to do the opposite of this. And the opposite of a square root is just to square both sides. That's all. So if we want to undo a square root, we're going to simplify it. I'm going to solve for x, so I'm going to square it. The reason I do that is they're opposites. The square and the square root kind of cancel each other out. X minus 4 equals, well, you have to square both sides because we're solving equations, right? Am I going too fast? I'll wait for you, please. So 12 squared is 144, right? That gets really easy, right? I'm just going to go plus 4, and I get x equals 148. Show me thumbs up. Was that easy? Yes. Right? That was easy. 148. So now let's look at example 2. Okay, with example 2, how would we undo a cube root? Can you do a cube? Do it to a cube. It's that easy, right? We do a cube. So we're going to cube this whole side, and we'll cube this side, right? Because what you do to one side, you have to do the other to keep it balanced. Well, the cube cancels the cube root, right? 2x plus 1 equals, well, negative 3 cubed is negative 3 times negative 3 times negative 3, which is a negative 27. Okay? And then it gets easy, right? Minus 1, then we'll divide by 2, but I'll show it, right? So now to solve for x, we'll just go minus 1, 2x equals negative 28, right? Divide by 2, x is negative 14, okay? How am I doing? This isn't bad, is it? I know you can do this. So example 3, before we do the squaring, we got to tidy it up. I'm going to say tidy it up. Before I do anything, I'm going to get rid of the 6, and I'm going to get rid of, so I want to tidy it up first. So before I do anything, let's just go minus 6. Just want to get it simplified. 3 square roots of x plus 3 is equal to 12, right? I still want to just simplify it, tidy it up before I square it. So I'll get rid of the 3. There's an invisible. What's right here, Victor? What's an invisible right here? Yeah, so I do the opposite of that and I divide, right? Yeah. Divide by 3. I'll have a square root of x plus 3 equals 4, right? Now, to get rid of the square root, what do we do? Yeah, that's it. Yep, we square it. The square cancels out the square root. I have an x plus 3 equals 16, right? Minus 3, 13. X equals 13. How am I doing? Okay, we're good, right? Now, on example 4 is a trick question.
Oh, bro, but I solved it. How's this trick question?
Well, and if you solve it, your answer is probably wrong. which, that's what I want to show you. So, if you see the trick, then you don't have to solve it, right? The trick is this. Square roots can't be negative, right? Fourth roots can't be negative.
So you're telling me x is not negative 5 3.
Yes, in fact, there's no solution. And I'm going to show that, okay?
No solution.
No solution, so let's do it.
So let's do what Luke did. We're going to take it to the fourth power, right? I'd have an x plus 3 equals 625. Did you get that, Luke? Is this 625?
That's not what I got.
I think it is. Negative 5. Hold on, double check. Yeah, 625, right? Minus 3. Minus 3. I get 622. Now watch. If I plug this in, I get the fourth root of 622 plus 3. What's that equal? I don't know. Hold on, I'll check real quick. Fourth root. Oop, hold on. Clear. Clear. Quit.
So was I.
Quit. Fourth root of 622. Oops, 22 plus 3. What's that equal? Equals 5, doesn't it? You see that? It equals 5. But it doesn't equal negative 5, does it? So let's write ourselves a little note so we don't have to work. So if we have any even root, okay, little note, okay, even roots. First of all, they cannot, even roots cannot equal negative numbers, cannot equal negatives. They can't. So it'd be no solution. And the other is this. You can't take the root of a negative number. No solution. So let me show you this before we move on so we can make this easier. Okay, I want you to see a couple of things, okay? Okay. If I try and take the square root of negative 4, okay? Square root of negative 4, right? Square root of negative 4, everybody see that?
Yep.
You'd think it's 2 or maybe negative 2, wouldn't you? Wouldn't you think so?
Yeah.
Oh, what's it say?
It's
Non-real.
So it's not possible.
It's not possible. Or if I took the fourth root, hold on, let me do the fourth root.
Wait, how did example 2 work in opposite?
Great question. I'm going to come back to that, okay? Really, it was such a good question, okay? Negative 16.
Because it was a cube.
Yes. Okay, watch this. Fourth root, watch. So you would think negative 2, wouldn't you think? Negative 2, but guess what?
Because it goes.
Now, odd roots are okay. Because a negative, Blazer, you're doing it. Because a negative times a negative times a negative is a negative. But a negative times a negative is never a negative. A negative times a negative is never negative. You agree with that?
Yep.
And a negative times a negative times a negative times a negative is never a negative. Right?
Wait, so negative times a negative times a negative is never negative?
No.
No.
So,
Negative
So how many fingers do we now show? How many?
3.
Odd number, right? Negative 2 times negative 2 times negative 2 is? It's negative. So 3 negatives can be negative, right?
If you multiply it.
But a negative times a negative times a negative times a negative is a, can never be a negative, right? So if it's an even root, it can't work,
Oh, that makes sense.
right? If it's an odd root,
This makes
it can work, right?
Sure.
Okay, let me keep going. How do we sit down, please?
Right, so Luke, what would help me is right here I would have said, wait a minute, fourth root, negative, no solution.
So if it's negative, it's no solution?
If it's an even root equals to a negative, no solution.
It's really important.
Okay, let me turn the page. Okay, does that make sense? Now, example 7. And we're not going to do 6 until Monday, but let's look at example 7. What I'm going to do is square both sides. Okay? Watch carefully. This is a harder problem. If I square both sides, the square cancels the square root. But on this side, x minus 7 means x minus 7 times x minus 7. X minus 7 squared means x minus 7 times x minus 7. I need to simplify this. X times x. X times negative 7. Negative 7 times x. And negative 7 times negative 7. Okay. I'm going to continue simplifying. Negative 7x makes a negative 14x. Now, this looks like a problem we did last chapter. Looks like we're going to have to factor. But before I factor, I want to bring these two terms over here and make it equal to 0. So I'll go minus x plus 5 plus 5. I'll get an x squared minus a 15x plus a 54 equals 0. Okay, and then we're not done. I don't know what x equals, right? So we're going to factor, right? Yes, x next to right. What times what makes 54? Anybody know?
It's like 20.
Wait, what was that?
Got it. 7 and 8. Nice job. 7 times 8. And does 7 and 8, doesn't 7 and 8 add up to 15?
Yes, it is.
Okay. Oh, no, we have 56.
Yeah, it's 56.
Oh, no.
9 and 6.
9 and 6. You were right and I was wrong. 9 and 6.
Who said 9 and 6?
Okay, now, we got our mini equations. What's x equal?
0.
9, positive 6, right? Now, this is another one of those trick questions, and I want you to watch this carefully. 6 won't work. Do you know why? If I put the 6 right here, what happens? If the 6 goes right here, what happens?
It's not possible.
Because it becomes a negative 1, doesn't it?
And you can't have negative.
Right, so we throw away the 6. And we'll do this on Monday, okay?
What do you mean by just throwing it away? You just cross it out?
You cross it out. We only have one answer, Emily, not both.